We're going to be looking at the Mount Saint Helens example. I've already got the image drawn. If we look at it, we have on May 18th, 1980, volcano blew, and we're trying to determine the height of the volcano after the top blew off. And so we have the angles at the bottom, which you can see 37 degrees 46 minutes is what we have for the angle. You can see that here. And then the second angle, once they took the second measurement, that would be 1,000 feet closer to the base of the mountain. And so they looked up and measured the angle at 40 degrees and 30 minutes. We are trying to determine the height of the actual mountain. And so to do that, we're going to be using trigonometry. The one thing we don't know is, even though that we know the distance is 1,000 feet closer between the two different measurements, we do not know how far the mountain or the surveyors were from the base, or really the center of the mountain, where we're going to be measuring the height perpendicularly. So what we're going to do first is we're going to go ahead and write out our equations. Since I have two things that are unknown, x and h, and it's most likely going to be that I'm going to have to come up with two different equations so that we can use a system of equations to solve for each variable. Okay, so here's what the first set of equations is going to look like. We're going to have tangent. It's because we're dealing with the opposites and adjacent sides, right? So when we have these situations here, it's one at the bottom, we're going to have to work with our tangent function. So the first equation is going to be tangent of, we'll do the bigger triangle first. That'll be 37 degrees 46 minutes. 37 degrees and 46 minutes. Let me go back and fix that. That should be degrees. That's equal to the opposite over the adjacent. So in this case, the opposite side of that triangle would be h. The adjacent side is a little larger. I have an x and 1,000 inside. Well, if we're trying to determine distances and have parts that kind of make up the whole, then we can take that distance. We can say, well, this part plus this part would equal the total distance across the whole thing. I mean, if you make sense of it, if I told you that this was 3,000, then you would say 1,000 plus 3,000 to equal the 4,000 distance. So be careful. A lot of people want to multiply there, but it's addition. That's going to be equal to, but h over 1,000 plus your x. So that's one equation. We're going to go back in. Let's write another equation. What we're going to do this time is we're going to pay attention to the smaller triangle located here with the second observation 1,000 feet closer. Still tangent. So tangent of, let's see, 40 degrees and 30 minutes. That one would be easy to convert. That's going to be equal to the opposite. In this case, it's still h over the adjacent. This time it's just the 1x. So h divided by x. And if you remember, whenever you determine, or whenever you're trying to define, or whenever you have two equations with two different variables, we have two primary methods that we use to solve these, and that's either substitution or elimination. In this case, elimination is probably not going to be the way to go. That might be a little bit tricky. So we're going to go ahead and I'm going to solve both of these equations for the variable for h. In that case, I'm going to substitute in and then be able to solve it with just the x variable. So you can see here. Before we do that, we need to go ahead and convert 37 degrees and 46 minutes into degrees, minutes, and seconds. Real quick, the way if you remember, it'll be 37 degrees plus, since this is only minutes, we're going to say 46 minutes over 60 because there are 60 minutes in 1 degree, and that will give us the number 37.76 degrees. If we do the other one, that's going to be easier, 40 degrees and 30 minutes. I really don't even need to think about that. 30 minutes is half of 1 degree, so it's going to end up being 40.5. So 40.5 degrees. Otherwise, you would still work it out the same way as we did up top, but 30 over 60 is a half, and we can all kind of think that in our heads. So let's go ahead, and I'm going to solve. We'll call this equation 1 and equation 2. I'm going to take equation 1 and I'm going to go ahead and work that out and solve it for h. So if you see up top, I'm going to take the denominator right here. I'm going to multiply both sides times this denominator. It'll cancel on this side, and it'll be on the other side multiplied by the tangent of 37 degrees 46 minutes. So I'm going to go ahead and actually include inside the angle, I'm going to go ahead and put the decimal equivalent that we found over here. Okay. So we're going to have 1,000.
I'm sorry, I think it's dessert time.
Plus, all right, let's get back. 1,000 plus x times, let's see, that was tangent of 37.76. That's going to be equal to h. Okay, awesome. That was easy. Let's do the same thing for the next one. It's going to be even easier to do the next one. So equation 2 is going to turn out to be, really what we're going to have, it's just going to be this part multiplied on both sides, right? So it'll cancel on this side. All right, here we go. 2 is going to be x times tangent of 40.5 equals h. Now that we have two things equal to one another, I can substitute it. And in fact, I really didn't have to solve both equations for h. I could have simply solved the first one, like we have here, and plugged it in for h at this point, and then worked it out. And eventually, I would have done the same exact operation that I did here. But we're just kind of going ahead. So we're going to create a new equation by setting this part equal to this part. So we have, and I'm going to go ahead and distribute this part into this piece and this piece. Lots of interruptions. Fantastic. So 1,000 times tangent of 37.76. Let's see. Plus x times tangent of 37.76 equals x times tangent of 40.5. In solving equations, one of our goals is to isolate the variable that we're trying to find and get it on the one side and get everything else away from that. You can see here that we have two different locations for x. We have an x located here, we have an x located here. I need to get them together, so we want to get this part on the other side. So we're going to subtract that from both sides, and we'll end up with this. 1,000 times tangent of 37.76 equals x, seriously? Let's continue. X times tangent of 40.5. This is going to be minus x times tangent of 37.76. Now we can go ahead and we can factor out our x from this piece. And so we can take that and we'll write it out as, let's see if we can get this small enough. So it's going to be x times tangent of 40.5 minus tangent of 37.76. And so at that point, what this allows me to do is allows me to divide both sides by all of this, leaving x by itself. So let's see if I can do this quicker. Let's see, I can take this and there we go. So we're going to take that, we're going to divide both sides. Draw my division. So we're going to use the other side here as well. So we're going to divide that. And what we see in this case, so they're really equal to one another here, this is going to cancel out, leaving me with just x. I'm going to take all of this, I'm going to type it into my calculator. And what that's going to do is it's just going to give me the value for x, and we'll have to go back in and plug x in to one of the two equations we started with to find out what my h is going to be. When you work that out, now I've rounded to 2 decimal places, so if you rounded to more decimal places, then your answers will be a little bit more accurate. When we do this calculation, you're going to end up with 9,704 41 feet if we round to the nearest foot. So that's telling me that's the distance that the individuals were from the mountain when they measured their second distance. You can see that right here. So this is the distance we just found. I've got a formula here that's going to make it easy for me to find h. So I'm going to take the 1,000, I'm going to plug in for x, and just work it out like this. And so that would look something like this. So 1,000 times tangent of 40.5, that should give me what h is. It would help if I used the actual x and not just my random 1,000. So let me correct that just for a second. So that's going to be 9,741. I don't know why I used 1,000. So that works out to be 8,300 and approximately 20 feet. Now I have rounded to only 2 places, so sometimes rounding more or actually leaving it in your calculator unrounded might even be a better way to do it. But our final answer would be Mount Saint Helens. After its explosion, after the volcano erupted, we would assume that it would be approximately 8,320 feet high. Remember, when doing one of these problems on a test, that your work is going to justify your answer. For example, if you got something a little bit off from me, maybe you rounded it a little bit differently, or maybe you were more accurate than me, I'm going to go back and I'm going to look at all your work and see how did you get to where you got. If I can't justify what you ended up with, then, and it's not what I have, then you'll lose points. But make sure to include all your work, okay, and it's readable, even though mine is rather messy. But if you have questions, watch this over again, make sure you know how this works. You can ask me when we get to class.